Okay, so welcome everyone. Thanks for having me. Thanks for coming and watching to a presentation on MongoDB. I'm very sorry, but my Italian is worse than your Portuguese, so I prefer to do this in English. If I go too fast, please just raise your hand, throw me papers, whatever. I can slow down, okay? No worries on that. So, who am I? I'm Roberto. I work for Tangent. I'm a solutions architect. Me and Bill, we take care of the, let's say, Italian market. Basically, we like to come here a lot to eat pizza and meet a lot of good people. This is why we are here, okay? If you have any questions whatsoever about MongoDB and a little bit about Java, you can either bash me on Twitter or hit me and spam me around with my email address. I will be happy to answer any of your questions or suggestions or critics on anything that you have in mind. So, first question is, who here knows about MongoDB? Okay, that's cool. So, who here is already working with MongoDB? Okay, cool. So, lots of, let's say, newcomers to the technology and to the concept. So, this talk is about giving you a brief introduction of what is MongoDB, what is this thing which has a very funny name, which is not very particularly good to be saying, yeah, I use Mongo for any good reason. So we're going to talk a little bit about the basic fundamentals of MongoDB. Then we're going to move into how to use it from the Java perspective, how to use it, which other language on JVM you can use MongoDB with, like for example Clojure or Scala. Well, how can you integrate with this with Spring Data, for example, or other ODMs like Morphia, which is kind of a popular one. And I had the intention of bringing you up on 3.0 new driver. I'll briefly talk about it. I didn't have time to add up the slides, but I'll send it to you, the final presentation to all of you, or to someone that can distribute it with all the new features on 3.0, okay? So, sorry about that. Well, everyone knows what a relation database is, right? Everyone, at least somewhere in their professional career, and all of us here, I think we are all employed and we work with one sooner or later. So, relational databases, we all know about, right? So, we know about SQL, we know about tables, we know about relationships, we know about entity modeling, relationship entity models, right? We all know about those boxes and all those arrows and end-to-end, one-to-one, one-to-one, those kinds of things, right? They've been around for a while now. They are one of the most used pieces of software that everyone somewhere in their life, in the software engineer life, will have to be using or has used already. But they are coming into a struggle. Nowadays, with all these new applications and all these new computational environments that we work with, like social networks, like big amounts of data, like real big amount of data, like new data formats, like new applications, like new dynamic languages, databases, relational databases, they are not well fitted for the task. They do not adjust well to our new methodology of software development. Like, who works here with agile methodology? Who would like to work with agile methodology? Okay, so who knows what an agile methodology? Everyone? I hope so. If not, agile methodology is something that allows you to fast prototype, fast iterate, and fast develop. Basically makes you more agile. It makes you build applications with a bigger smile on your face. Why? Because you fail faster, you can correct faster, and your boss can see your improvement faster. So basically that's a big paradigm shift in the way we develop software. Relational databases usually have a problem for that. Why? Who here is a system administrator or DBA? Okay, cool. You are. Nothing against you, okay? This is not a attack against you, but usually there are a lot of restrictions, and those guys, they have a lot of pain in their shoulders. Why? Because we developers, we develop applications according to the way we want to interact with the database. Not specifically how it's optimized, not specifically how it's better suited. It's more basically how do we want data in and data out, or how do we want to organize our data. Relation databases usually puts a big toll, a big restraint in the beginning of developing a software, because you have to pre-ahead define all the schema, all the constraints, all the field data types, all the foreign keys, all those indexes and so on, that actually are a lot of work to do. So ahead of your starting to develop, you have to think about how do you want to organize the data. One of the problems with that is that, for example, if you have a new architecture like a cloud computing software, where you want to run it on the cloud, and it's mostly bounded to the way that your users interact with that data, you do not have pre-ahead, well-defined how your data is going to be layered down, how you're going to use it, how you're going to show it, how you're going to manipulate it. So this is a big challenge. Another big challenge is that usually changes, data migrations on relation databases are not an easy task to do. Usually they involve a lot of team, a lot of different members on the team, a lot of different managers on the team, a lot of different requirements for each individual teams. So every time I need to change that data from one data type to another, I need to talk to my DBA and ask him, can I do this? And he's going to tell me no, because that's what system administrators should do. They say no, 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 till we say yes. Okay? This is how it works. And it's the way it should do. Because every time we demand a change, probably affects other people that are also using that database. And a lot of politics gets involved. So you have new architectures, new data types, agile development that demands a lot of iteration out of your systems, out of your DBAs and so on. And most important of all, the volumes of data are changing. We do not deal not anymore in the terabyte scenario. We are developing applications for the petabyte scenario, like the Facebooks, like the LinkedIns, like the Googles, like Telecom Italia. They are the ones that actually ingest. I'm just saying Telecom Italia because there's a general here. So they are building the next generation of big data ingestion kind of scenarios. And we need to consider those in our day-to-day new application that we're building right now. So looking at the landscape of the databases, you can see a little bit of more or less this kind of scenario, where from one side you have a very, very fast key value memcached kind of scenario, where those databases or data stores, depending on the concept that you're trying to use or trying to define them, they are very, very, very fast. They are used especially for data caching, very fast access, reads and writes. But they also have very limited kind of operations they can do. More than insert, update, and retrieve, you cannot do that much. Most of them also are usually an in-memory database, which means that once you unplug or disconnect the server, you basically lose that instance of data. Okay? Does anyone here know Redis? Okay. Yes. I like Redis a lot. Okay, it's one of the most wonderful pieces of technology with PubSub. You can do queuing systems, you can do a lot of notification systems based on that. What's the problem with it? It's basically very simple. You cannot do advanced querying, you cannot do a lot more than just fetch by key and store by value. On the other hand, there's the relation database that everyone knows. So if there's a piece of software that actually is very full-featured, which you can even program to it, even some of them have their own PL SQL engines where you can build all your business logic on a store procedure. Those are the ones. Okay, you can build anything on top of it. What's the biggest problem with that? Does anyone know? Does here everyone likes to deal with those 20,000 line queries?
Nope.
No, right? Is it easy to debug?
Nope.
Who builds store procedures? You do. Are you a DBA? Do you work closely with DBAs? You are a rarity, my friend. So most of the cases, who builds the store procedures are actually DBAs, which it's fine if they know what they're doing, but they are not developers. Their job is not to make efficient code. Their job is to store procedure and get the queries that the developers are too lazy to understand or too lazy to do themselves. So this is why you can run into a lot of scalability problems if we derive all of our code into a database. It's basically shifting the responsibility of the application back to the database, where I don't really think where it should be sitting anymore. So MongoDB wants to position itself right in that sweet spot where you still have a lot of performance, you still have a lot of efficiency, but at the same time you can still do a lot of stuff with MongoDB. You can query on secondary indexes. You can do any kind of operator for match and find and query by store procedure, no, but query by regular expressions, query by range type queries. You can basically have aggregation framework to do your analytics in your group by and so on. You can even do MapReduce. And actually you can build complex systems based on your data layer and extract those data, that data out. So, in general terms, MongoDB is a document-oriented database. Okay, it's open source, so I invite you all to go and clone the MongoDB project back into your computer. If you know a little bit of C++, and if you're very good at it, go have a look. It's very well documented application. It's easy to start getting into the notions of it. You are a Java guy, so maybe you can download the Java driver. It's better to start that way. Participate, make critics, get involved. I think we all benefited at the end. It's high performant and horizontal scale by definition. This means that we built MongoDB to do exactly that. We want it to be very, very fast and want to be able to grow horizontally. And it's full-featured. We're going to look into more detail about that. So, document-oriented database means that our dataset format is JSON. Does not mean that we are storing PDFs and docs. Okay? It's not the same thing. Even though we have something called readfs that actually allows you to store in MongoDB all those binary format files. We store information internally not as JSON but as BSON, which is basically the same thing but in binary format. If you have curiosity in looking at the exact format of it, just go to bsonspec.org. Okay? And the good thing about this, it integrates pretty well with your native language. Do you guys know what JSON format is? Do we use it? Do we like XML? No. This is why JSON exists, right? So to have a neutral format that we can interchange data with. And it's easily mapped to any object-oriented language. You can use it on PHP, JavaScript, Scala, Java, C++, C#, you name it. Almost all languages basically have a nice port between objects and JSON format. Okay. Oh, open source, yes, you can go to GitHub, use it. The database license is AGPL, it's a Faro general purpose license. Basically means that Tengen, which is my employer, decides how the project is going, but it definitely listens a lot to the community that uses it. So if you have any critics, if you have any enhancements to propose, please do. We are more than made it open to suggestions and new improvements. And if you can code, please go ahead and submit your patches. And also, all the drivers are under license of Apache, so you can build your own. I'll explain a little bit how it works internally. If you do not like our Java implementation, and I have a lot of critics about it, this is why we're going to do a 3.0 version, then you can build your own. It's not that hard actually. So, we built this thing to be high performance and highly scalable. Okay, what do we mean high performance? Well, we mean high performance because and this, I know it's very hard to do it in a Java user group, but we've done it in C++. We could do it in Java as well, there would be no problem. But some guys say that C++ is more efficient. No flame wars here, okay? We do data serialization in BSON. We parse JSON formats or objects, documents in this case, into BSON. It's pretty straightforward. It's a full support for primary and secondary indexes. Primary is your primary key. All documents in MongoDB need to have one _ID field, where we always use to identify uniquely each one of those documents. But that doesn't mean your query capabilities are limited by that. Doesn't mean you always need to know your _ID. So you can query on any field. If you can query on any field, probably it's a good idea to be able to index on those same fields to optimize the queries. We also provide horizontal scale. And horizontal scale in MongoDB terminology means sharding. Sharding is a terminology where you allow your system to partition your data according with the range. And based on that range, you can add up multiple nodes of data holder nodes to your system, to your cluster, so you can spread and keep on growing the amount of data that you ingest and that you need. So, you guys, which database do you usually like? MySQL. Everyone knows about it? Okay. So, who here had the problem of changing 1 million rows in one table and changing from char2 to varchar? No one? Okay, 100 million rows. Has anyone got that? So previously I ran into a problem in a previous job where we had to change, just because we needed to save space, a row in a column in a table of 1 million documents, 1 million rows, sorry. It took 1 month to compute that change. It needed. So maybe we could do it in a better system. I doubt it. It was the only way to do it. Maybe we could do it in a different way, in a batch process way, just migrating data around and so on and so forth. But the thing is, when you get into a situation like that, your constraint is the amount of data that you have. It's basically so big that the relation database will not be able to handle it right. So then you start doing things like denormalizing your database schema, meshing up all into one single big table. And then you start doing your custom sharding, like say you have different instances of MySQL and you start putting from month 0 to month 5, it goes to one cluster, from month 5 to month 7 goes to another cluster, and so on, so on, so on. And then you enforce those sharding capabilities in your code, so you can know exactly where to fetch data from. Okay? This is a typical scenario. What's the bigger problem with that? It's unmanageable. It's very hard to maintain. Your DBAs will be screaming at you constantly, and you will have a lot of performance issues around it. MongoDB, this is all for free. Well, kind of. But it's very much more automatically managed, and you do not need to know about this. As a developer, and from the DBA point of view, it's much, much easier to administer. Full feature because you can query on any field. You have a multiplicity of operators to query on. You can do range queries, match queries, regular expression queries, in queries, out queries, exist queries, those kinds of things. You have real-time aggregation, so you can run your analytics jobs in an aggregation framework on your data sets. You do not need to export that all to raw information to an Hadoop cluster to run it all. You can do it immediately on your operation data set or in your secondaries even if you want to. It's pretty cool. Has geospatial features, which means that if you have geolocated information and you want to correlate that with a map, or correlate with that with distance, or you want to correlate that with a polygon of any kind, you can do that with MongoDB. Does anyone know here Foursquare? Okay. Foursquare uses MongoDB exactly for that, to hold all the check-ins. So every time you go into Foursquare and you want to know where your friends are, you are doing a query on MongoDB. Quite recently there was this probe that they sent to Mars, which is called Curiosity. Curiosity made a check-in in Mars. So MongoDB is so cool, it even has check-ins from Mars. Okay, so it's how cool we are. Another cool thing about it is that we integrate very, very well with native languages. So we have supported, officially supported means that we hire someone to work specifically to make it very, very good and very bug-free driver. We have about 12 of those. And there are around 25 different languages and frameworks that have their own build or their own driver for MongoDB. This is how far you can go in terms of, if I want to use a language, a particular one that's very well known, probably there's going to be a MongoDB native language integrated driver for it. Okay? Even Haskell as well. So. Also, MongoDB is built to allow full consistency of data. Okay? There are lots of NoSQL technologies out there. Some of them are also document-oriented, but none of them enforces this by default, which is you always have one single point where all your writes go to. So if you always want the latest accurate data or the fully consistent view of your data all the time, with MongoDB you can assure that. Okay? Also, it has automatic failover, which means that if your primary is lost, there's a secondary that can be in place that will take its role as a primary through an election process, a very democratic one, where the freshest copy of data holding node, the one that has last ping time, and the one that has higher priority will take place and become the primary. Okay? So you can always guarantee zero downtime for your writes if you build your application correctly. Okay? So you also can offload some of your reads if your application, for example, allows certain type of eventual consistency. Let's say you do not need all the time the most accurate data for some kind of reads. Let's say, for example, you have a log viewer, some application that just plots graphs into a dashboard that gets that information from out of logs. You probably don't need the last insert on the millisecond level. Maybe what you need is the last second view, because at the end what you're going to do is aggregate all that and put it on points in a graph, so the precision of that might be irrelevant if it's not very delayed. So you can offload some of those reads into secondaries and plot those graphs away. So how do we do all this? How are we so great? How are we so performant, and how people like us so much? Well, MongoDB uses a memory mapped files as their data structures. Does everyone knows what a memory mapped file is? Yeah? So basically memory mapped file is a resolution of all that data in file, which is mapped directly to virtual memory, and from virtual memory the operating system decides which parts of those sit in memory or not. So basically we are offloading the responsibility of what is in memory all the time to the operating system. why do we do this? Because the only real entity in your server or in your node instance that actually knows what's going on the overall machine is the operating system. It should be the one that decides better which portions of data sit in memory and should sit in memory more often. Okay? So MongoDB does not take responsibility on what's allocated to memory all the time. It's the operating system responsibility, and it does it very, very well. Okay? Usually. So we use, for indexation, we use B-tree indexes. Okay? Most well-known algorithms to search. As everyone knows here what a B-tree is. Divide, 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 divide till we get your data. Files are also pre-allocated ahead, means that every time you need to write more data than the one you have available on file disk, we pre-allocate a new extent of database file. This means that we are going to be very, very, very efficient on Verilog file systems. For example, XDF4, ZFS, NTFS, those work well with MongoDB. XD3, for example, does not work so well. Okay, something that you should add into consideration. So, does everyone know what this is? Right, the thing I was jiggling about in the beginning, right? So the entity relationship model, right? So if we are going to do based on the way we've been told in school or in university, how to build an application, we start from the bottom up, right? So where do we store our data? Because data needs to be stored somewhere. We start building boxes like this, okay? And we define, okay, there's a tag, there's an entity, there's a user, there's an article, and so on. And then we link them together, and we set it up as, okay, this is the way that I'm going to manipulate data. If I only want the users, I go to this table. If I only want the comments, I go to this table. But by the way, in any blog that you know, how many times do you go just to check the users? Think about this. In any blog application that I get into, any portal, when is the time that I actually need to fetch just from the users table? Do I need to do that only? Ever? Most chances is that rarely. Okay? Maybe if you are on the back office of that blog application and you need to grant some permission to some blog or whatever, maybe there. But how many of those requests represent a significant amount of volume of traffic or interaction for your application on that? Very, very small, I'm pretty sure. So why do we need to isolate this? If our application, the code we are building to show the information, actually never uses an entity that is just user. It always uses user in its articles. Pretty sure. Or the user in the comments you made. So in MongoDB we take that forward and we say, okay, so if we do not need to submit just the user, or if we always need to do the article in together, maybe it's a good idea to have them all mixed together. This has a huge effect on the way we seek data, or fetch data from disk, or we fetch data from the memory. Because every time I'm going to access the article, I'm going to get all the information I need. Probably I don't even need the user. I need the users to be a subdocument of my data structure. Okay? Because that's the most common query that I'm going to do. The one that I really want to be fast on. I do not need the users to be a one single seek. I hardly use it. What I do need is every time someone goes to my blog and asks for and clicks on the link, that information needs to go out the room very, very fast. Also, reliability is assured by the single master writes and some eventual consistency if we want to. It's not by default from secondaries. Okay. If you want to read from secondaries, you need to explicitly say to the system, yes, I really want to read from secondaries. Okay. And then we have auto sharding to enable scalability. Basically, a shard environment is composed by 3 basic elements: MongoS, config server, and a MongoDB. MongoDB is a normal database process, the one that's actually going to hold the data. It's going to be primary or secondary depending on the replica set it's in, on the priority on the data that is holding. Okay. Then you have config servers, basically hold the mapping of my shards. They will tell me, okay, shard 1 will have information from 1 to 10. Shard 2 will have information from 10 to 20, and so on and so on and so on. And the MongoS is basically the one that communicates back to your application. So if you are on a Tomcat, you're not building some kind of GPA or something like that, and you need access to database, probably you should be able to enable this through MongoS. The difference between accessing directly a MongoS or a MongoDB, 0. It interacts in the same way. The only thing is that this guy knows a lot more data than the MongoDB individual. Okay? I'm talking a lot. If there's questions, please feel free, okay? So, if we want to do a comparison and we want to do an analogy between the terminology we use in relation database and a MongoDB terminology, let's say, a table and a view is going to be a collection, a row will be a document, an index will always be an index, a join, we can achieve that by linking and embedding documents, subdocument, and so on. Partition is a shard, and a partition key is a shard key. Okay? So, I want to start building my stuff with MongoDB. What can I use? Does anyone know, almost have an idea how many languages we have in place? Do you know all of this? Okay? So these are the ones which are basically officially supported by Tangent. Okay? We are the bigger committers for these projects. They're all open source. Okay? You can check out the code. I can show you a little bit of the code as well. We are responsible for maintaining it bug-free. We're responsible for maintaining them up-to-date on the new evolutions of the server. Okay? If you're using one of these and you run into some doubts and you go to the MongoDB user group or put some doubts around it or questions about it, most probably it's going to be a Tangent employee answering your questions. They might not be very sympathetic. I cannot assure that. If it's me, I will be sympathetic with you guys, don't worry. But they will be fair, and they will tell you exactly what it is because they coded it, so they should know. Okay? So it goes from Ruby to PHP, Scala, C, .NET, Perl, that thing over there, Java, Erlang, and Node.js.
What's the first one?
Sorry?
What's the first one?
I think it's...
Maybe Clojure.
I think it's Clojure. I'm not sure. No, Haskell, yeah, that's the one I don't like. Yeah, exactly. It's Haskell. Okay. So, yeah. There are two that I'm not particularly that fan of. One is Haskell, another is Erlang. But Erlang is cool, by the way. Anyway. So, there's missing one here, which is a very important one, which is JavaScript. Okay.
Node.js.
No, Node.js is over there. You can already see. Well, Node.js in JavaScript are mostly the same, but when I mean JavaScript, I mean the shell. Okay? When every time you press Mongo on your server, you are accessing it through a JavaScript interpreter, which is the Mongo shell. Why we build it in JavaScript? No idea. Now, it works well. It really works well. It has its ports to get access to the C++ driver, which the Mongo shell uses. pretty much very flexible data language to manipulate and to transform and to get started very, very quickly. So it might be a very good choice for an interpreter. I would prefer much more to use Scala or Python in that place. You cannot fight historical reasons, right? So we have 13 languages, and the community supports a lot more. Under these 13 languages, there are, for example, in the Java environment, also not only the Java official driver, but there are ODMs like Java, Spring Data and Morphia, for example. Okay, those are ones that people also tend to use because they integrate well with the Spring framework and so on. In the Python environment, there's the Django engine or Mongo engine for the Django framework as well, to integrate well with the Django. In the Ruby, there's a couple of them. In Node, there's, for example, Mongoose, which is an ODM. It's not precisely a driver, but it allows you to communicate directly without needing one. So there's a lot of those supported by the community. It's just a matter of going big. Okay? So the drivers basically abstract you from TCP wiring protocol. The way you communicate with MongoDB server is always through the TCP layer. It's basically bounded with TCP connections or messages that are interchanged between the server and the client. The MongoDB drivers abstract you from all of that and give you a native language interface to manipulate MongoDB. Okay. So if you are thinking about building an application in Java, I definitely recommend you to not use anything else besides the MongoDB Java official driver. It's on Maven repositories. If you are using Maven to build your code, it's just as simple as add dependency, put it in the version that you want, works fine. I can show you guys how it works in a few moments. It's not so hard. So the Mongo shell is not a driver, but it looks like one. Okay? Why? Because it allows you to type in commands in JavaScript. Okay? You can manipulate anything from the shell, pretty much similar to what you can do from the MySQL interface, the client that MySQL provides. You can use tables, you can use databases, you can show databases, you can insert, delete, do whatever you want to, MapReduce it, you name it. At the end, it's not a driver, but since you can do stuff like, I know this is a Java group, but I really like Python, so sorry about that. So I don't know if I have an instance running. Yeah, I do. So this should be like the Java, the JavaScript shell. You can, it's going to be complicated. You can do, for example, show DBs. You have one that's test. You can use test. Do you guys know this syntax from MySQL, for example? It's very common, right? You can show the collections. I was using this HT media one. And you can do, for example, a find. Can I see that I've been building some kind of scenario where I'm simulating some emails, I'm doing some stuff, don't worry about that. So you can see that you can start manipulating data very, very easily using a shell. You can go here and you say, okay, let's say that I want to delete this one in particular. Well, let's say by mail, maybe it's faster. Media. You can say, okay, remove this, please. Well, do I need to pass it on? I just need to pass it an A. Another JSON object, which in this case is going to be mail. Yeah, just look. Okay. So what it will do is we'll send this instruction, this document, back to the server. And every one of these documents that matches this email, I will know, I will delete it. So We do this, it will go through a lot of them. There's like 500 million, that's okay. And if I query on them, I also do the same mechanism where I send in a document where it basically will match all documents that has this inside. If these things work well, there should be no one. No. Okay, so it works. Okay, so we can find data, we can remove data. Of course, we can do all the CRUD operations in it. We can ensure indexes. We can do a lot of stuff here. Okay, just to show you a little bit how it works. So installation as well of the drivers are also associated with the common repository systems. Okay, so we have NPM, we have Maven for the ones who like Maven, we have pipe or an easy install for pip, an easy install for Python, Peckle for PHP, Gem for Ruby, and so on. Okay, we also have integrated builds for the server itself. So if you have a Debian or Ubuntu system, you can also have ptget install from our own repositories. You have Yum as well for Red Hat, lots of things. So we try to make it easier for your environment, for your ecosystem to build on and to use it. Okay, so let's go to the sweet spot that brings us all together. How often do you guys do this meeting?
Once a month, usually.
So once a month we come here and talk about Java, right? So let's talk about Java now. How do we integrate with the JVM and Java in particular? So we have a core Java driver. We have a Python driver which is basically related with JPython, not necessarily with Python. It's also Python anyway. There's a JRuby driver as well. There's a Scala build which internally will make a port use the internal Java driver, but also we have the Kashpa, Salad, which is a special kind of ODM on Scala that you can use. It has its own protocol to communicate back to the server. We have the Clojure community with Mongo. So this is not a supported, officially supported, but it's very nice and it works very well with Clojure. Does anyone here does any Clojure? Do you guys know Clojure?
Yeah.
I was astonished by the functional development that I saw in Nice. We've been into a Scala Clojure meetup. We went there with a very similar presentation as this one, and there was this girl doing a presentation on Clojure. It was rocking. It was really nice. I really have a lot of curiosity in learning it because it's a completely different way of building applications, functional wise. We also have higher level frameworks, ODMs, things that everyone likes, right? So who here likes Hibernate? You like Hibernate? Oh, no, okay. So who here uses Spring? Okay, you all work for enterprise, right? More or less. So there's integrations with Spring Data. There's integrations with not with Hibernate, thank God. There's integrations with also one particular one, which is Morphia, which was built by one of my colleagues at Tangent. So there's a couple of things around the JVM that have been built so you can make it easier for people that know Java to use MongoDB yet. So how can I use the Java driver? Okay. So these are going to be very basic examples. The people who already worked with it probably already been through all of this. Since we have a very, let's say, young crowd in terms of MongoDB knowledge, let's keep the basics. So every time we want to use a distributed system or use some external system, we need to connect to it, right? So if it's a HTTP request or a IP REST, we need to connect to it. We use HTTP protocols to do it. Every time we try to use a relational database, you're probably going to use a driver on ODBC or GDBC, right? Something like that. In Java, you do it like this. Okay, you have an instance which you can find in that library, MongoDB.connection. You set up a Mongo client. It's our preferred class to communicate with MongoDB. And we just tell it a server name and a port. Bam, that's it. Okay? No huzz fuzz, just the Maven dependency include Maven Java driver or something like that, or MongoDB, something like that. Oops. So before starting to do anything else, let's find out. So the dependency will be Java driver. Okay, simple as that. Okay. Do you guys use Maven around here? Who does not use Maven? How do you do all this class path thing, man? It's right, eh? You're my hero. So, let's get back. So you just import it into your Maven project and you start rock and roll. Okay? You include it, you start creating, you also have a instance to manipulate the access to database. This is necessary to access a concrete database in your MongoDB instance, but it will give you a lot of helpers for example, give me the statistics on that database. Number of objects, number of collections, access to collections, create indexes, drop collections, all those things. Also have access to a collection, which is basically a table. It's not more than a Java instance that you can manipulate. It's just another ordinary object where you can launch queries, run queries, updates, inserts, deletes, removes, create indexes, and so on. Okay? There's a lot of different functions and helpers. You can propose new ones as well. I invite you to go and watch the code. So, if I need to, a database is needed to store data. So let's insert some data. So we start like with a simple kind of scenario like this, where we establish a collection, instantiate a collection, simple as that. Can you see well? Yeah. Then we basically create a particular object which is called DB object, which is its instance. Its interface is like this, but the most common implementation of it is DB basic DB object. Basically, it's a extension of a map, okay? Where you have a key value, but you have a key value mapped, so you can have keys or values or maps in the documents and so on. This is the major critic I have on the driver. Every time you use, for example, the Python driver, you use a dictionary. Every time you use a PHP driver, you use an array. Every time you use a Ruby driver, you can use perfectly well a linked list or a named list, which is basically native supported language objects. In Java, we don't. Okay, we have this instance that we say as DB object. Has its reasons, because Java is not, a map of Java is not necessarily so good to manipulate into JSON format, but it could be something a little bit more elaborate. In any case, this is basically a way of creating your objects and mapping your POJOs to MongoDB objects. Okay? So, if we have, for example, a blog post or a book organization application, we just put a field and a value, and put another field and another value. If we need something more elaborate than that, like a subdocument, you can do that, where you say price, and the most recent price, this one. Okay? This will build us a document like, well, this slide needs to be better worked. So this would build us something like this. We would have title, something. We would have tag, maybe. We would say Java. Then we would have price. that would be something like this. And most SRP, so. And we could have like currency. Someday we're gonna have it again. Okay, so this, if everything goes well, of course. So this would be the output of that JavaDB object. Okay, once we insert it on the database, we will have something like that. And then to insert that, you just need to generate a call or select a call to insert method. That's it. Difficult? Try it. Okay? It's easy. Just please go for it. So how do I query? Now that I inserted data, I really like to query back in, just to see if it works. So we go through the same process. This time let's make it a little bit more fancy. Let's use some operators like range-based operators. So let's say I want to query all books that have a price higher than 40. So basically what I need to do is So basically what I need to do is build a new object, which I'm going to call query, the same way as the previous example where we set up a object, a DB object, a basic DB object, and we set a structure and send it to be inserted. The same thing we use for a query. We are building a JSON document that we are going to match all of our documents with. Okay? So basically what we're creating is, give me all tag name Java, and where the price is lower than 40. This is what I'm going to. So the output result of that is going to be a cursor, so I'll need to iterate over that. Okay? No different than any other database system. Okay? So also can use a helper from the database driver, from MongoDB driver, which is Query Builder. Yeah, basically have a couple of, let's say, helpers, methods that will allow me to build our query without knowing the exact operators like $LT, which is lower than. So basically I would say Query Builder start with price, and price is less than 40, and tag is Java, and give me a get. It will return a query object exactly as the same as before. This is a way of building it in a more controlled way, okay? Without you needing to know all the operators by heart. Okay, and then you send the query back to the system. These are basically the same thing, okay? So how do I update? How do I define an update in SQL? I just say update set value equals something where blah 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 blah, right? I need to define a query to update on. The same thing in MongoDB, no different. So we start with this, where we have a collection that we want to update on. We have a where clause. I'm going to say, okay, I want to update everything that has a price, tag name equals Java, a price which is lower than 40. And actually what I want to do is raise the price of all those documents. Okay? This is basically what I want to do. So what I need to is set price and increment that value. As simple as that. Okay? Do you know how much I'm going to increment that value? Of course you don't. You still don't know how to use MongoDB in Java. So I'm going to tell it to increment 5 on the price of this operation. So at the end, I will end up with something like this. I will want the title to be something, but that doesn't really matter. I'm removing that. I would set the price I want to increment five like that. This would be the operation I would be inserting. Okay? Changes a little bit the way we think about it, because we still first need to tell, okay, increment this by this value. But once you get it, it's pretty straightforward. Okay? Doubts on this one? All okay? Cool. So once you get this, you just need to call the update method, tell it the where clause, and this is a typo. Then I need to set the increment. What was here? Okay. I want to tell it who. What do I want to do? If I want to do it as a update on insert, which basically is if there's no document like that, I will create it. Create on insert. And true, this last flag is for all values. By default, if you don't tell it anything, MongoDB will only update one document. If you set it true on multi, you get it all. Okay? So there's another thing you can do. Imagine that I have a document that doesn't have a specific field on it, and I want to add it up. So I want to set a new field to that particular document. The same thing happens where I have a where clause, and I'm going to take everything that is lower than $40 or whatever, or lira. I'm going to set a new field which is labeled equals cheap. Okay? Now I'm starting to manipulate data differently. Now I'm going to have, for example, documents that don't have that field, but I can add up new fields as I go. This is very, very, very flexible, the way you manipulate data. Your data structures change. Okay? So, deleting is no more than this. We get a collection. We said, what do I need to delete? And then you enforce it. Simple as that. Also, if I want to get the result back saying, okay, cool, how do I know that it's been deleted? Anything. There's a write result at the end of each operator that I'd like to receive, and I can print out the number of deleted affected by that operation. Okay?
I guess there's one also for updates.
Yes, there's one for everything. Okay? Except for insert, which is only one, unless you do a bulk insert, which is another feature. I don't have time to put it on the slides, I'm sorry. But you can always go there and find all of it. Okay? So, all the information you can find, it's on API mongodb.org/Java. Okay, there you have the Java doc for the whole driver. You have the GitHub, where you can find the release notes, be updated, up to date on the new features that we're adding up. You can go to the Jira. You can submit tickets. You can submit issues. If you find bugs, please do. The only way of resolving it is to raise a flag and say, hey, you bastards, this is a bug that is busting up my build, please fix it up. And there's also the MongoDB user group where you can submit community questions. Most likely it's going to be someone from Tangerine answering, probably someone else, maybe an Italian ones. Okay, maybe Raffaele can answer some of them sometime if it's not too lazy. So, what other things do we have for the JVM? So, we used to have all of those, but those are the ones that we actually support and we use on JVM. JRuby, JPython, or Jython, or whatever it's been called nowadays. Java and Scala. Jython, this is the name. So, basically it allows you to run code using the JVM written in Python and using to communicate to MongoDB the Python driver. Okay? The specifics of the implementation are not that complex. They are not different than just basically hooking up JVM to dynamically loading some Python library the same way you would be doing it in any other library, okay? It will be as performant as any Python, Jython in this case, application, okay? You also have the same thing for JRuby, okay? But please do not do one thing, which is run Rails, build code on JRuby, and invoke the Ruby driver. It's madness. I've seen people doing it, and they will blame 10gen for their code running slow. Okay? This is not really how it should be working. If you're working with JRuby, do everything in JRuby. Don't mix up Rails and then play it in Heroku and then call the Rails driver. Things will not work well. Also, we have Kashpa, which is basically the driver for Scala, and it's pretty much the same architecture as the previous ones. It will wrap the Java driver, the official Java driver, and make it offered to you through the Scala interface. Okay, it's not more than using math library from Java on the Scala. The good thing about it is that we provide an idiomatic interface to using Scala language and not Java language. Okay? So, pretty cool stuff about Scala. I really like Scala. Who really likes Scala? Okay, this is a joke. I'll stick with joke. Okay, so Scala for me is good stuff about dynamic languages with strong type framework. It's nice. I really like it. Why? It can be very, very powerful in terms of performance, but also does not compromise anything that you have been doing for the last 20 years. This is how long Java has been around, more or less. So it does not compromise that. You can still use anything that has been built on Java. Let's put a little bit of salt on it, but still you can do it. How do you use the same kind of thing? Well, you need to basically create a class saying all those fields are my class objects or my class arguments, and I just need to define a 2DB object and map it directly. We call this and it stores information. Okay, so when we want to insert data, we basically call Mongo clients, we call the bookstore database, the books collection, and we insert it. Simple as that. Okay? That was the way we were doing the connection. This is the way we interact with it. Okay? You can have also special builders, you can invoke, you can instantiate. It's pretty straightforward. Does this sound like something strange from the Scala perspective? If you don't know Scala, of course, you always going to be looking at this strange, but this is pretty much the same kind of language syntax that you could expect from any Scala application. Okay? So, if you want also to do queries, you can do them, no big deal. And I'm going to go more fast forward on this because we are not very interested in Scala anymore. So there's also a couple of Scala community drivers. There's Reactive Mongo and Hammersmith. Okay, Hammersmith was still is a product of an ex-colleague of ours, which used to work for 10gen. Now he works for Peptide. No, what's the Scala? TypeSafe. Okay, you guys know it. So he's very good doing these things. Okay, he's very good doing what he's doing. Otherwise he would not be hired by TypeSafe. So you can rely on Hammersmith quite heavily if you want to build something related with Akka and all those things. Reactive Mongo, well, has replica set support, has authentication support, readfs, process, bug inserts, database command support, Unix operations. Pretty much the same thing. This is a little bit of how it would be operating in terms of querying, for example. define a cursor, define a query, apply it, and iterate over it. It's kind of a mixture between JavaScript and Python and Java all together. It looks like it. That's why I like it so much. Okay, so pretty much what it is. You can do pretty much everything in the same kind of Scala-ish way. Okay. Then there's Clojure. Clojure is crazy, but it works. So, for example, if you want to access a database server from Clojure, you need to define a namespace, and you define a function that requires Mongo, and then you need to import Mongo option server address. This is basically a Java driver class that you are basically importing. Okay? Then you just send a connection, you define a function of connect, and then you set a database. Easy, right? It's crazy. So if you want to insert a document, you create a function that is called documents, and you send in a JSON document, and you close the function. Okay? It's really crazy. I really was astonished at the way this works. It's all functional programming. We do not do classes or objects anymore, just everything's a function. So, higher level abstractions. We have Morphia. Does anyone here know Morphia? If you're not that familiar with MongoDB, you probably don't. Basically, Morphia is a way of annotation-based programming, so you can actually use MongoDB without needing all that boilerplate, without needing to know the scheme or the collection or any of those concepts. So you just define an entity, define all the fields of that entity, pretty simple, and then you define for example, the extended structures in it. You can have lists, you can have arrays, you can have subdocuments. For example, there with that annotation ID, we are defining already which field we want it to be an underscore ID field. Okay. And then you start embedding documents. If you want to embed the class in it, for example, you have price as a separate object. You can set it as an embed. You'll basically create a subdocument in your MongoDB JSON document, and you go on and on and on. Reference will allow you to link to a different collection. Okay, so you have, like in this case, we'll have a author collection and a books collection. The way to symbolic link it is through reference. And then you can also have a property where you can change the field name that you want to store in different from the way it's named on your object. Okay? Makes sense so far?
Yes.
Okay, then the interaction between it, they have all the methods like from insert, delete, update, and so on. Spring Data. Lots of people here use Spring Data, or at least use a Spring framework, so annotation away. Okay? This is annotation based. You can define the document, where you want to store it, or where it will be stored. You can have also the same type of notation for IDs, for example. You have subdocuments, you have DB reference, where you want to link to the other collection in your MongoDB instances. You can have a field and change the name of the field. Instead of using year, you use publication year for this case. Okay. How can I configure it? It's basic XML, like everyone likes, right? Cool. So the big problem about Spring in general, in my view, is that it's mostly you end up coding XML instead of Java. I don't really like that.
That was 10 years ago.
Yeah, I know, but you actually, the good thing about it is that Spring, you do not need to do a single line of XML. The reality is, you do. You do a lot, right? So what's the problem with XML? It's very hard to read. It's very hard to maintain. It's not something sexy like JSON format or an annotation. But really, it's really complicated to debug on XML. My view. Maybe I'm very limited, so this is why I like Python. I don't know. So, how do we define it? We can define a MongoID instance. We can set out the retry. We can use the Mongo template. Mongo template is a helper or wrapper on top of collections that allow us to do a lot of stuff. Like, for example, define the constructors, define how the values are going to be defined, where you can find in user repositories and so on. Then how can we invoke it? Well, simple Spring way. You define a context of an application, you load it, and then you start using the beans. Simple as that. Okay. Good thing about this, it will allow you to abstract a little bit out of your database, if you want that. Okay. So, I need to get a bean for my Mongo operations. I set up a book. I go to operations and I insert it. Simple as that. Okay, everything is configured on the configuration XML file. We do not need to touch any Java to boot it up. It's all bounded to the XML, and now Spring works. You can do anything like find one, use the Java driver as it could be. Okay. Here for querying a little bit more, passing on objects, direct objects, without the need to go through all that basic DB objects to build your own queries. Okay, you can go directly through Spring Data. Yeah, the interfaces they can extend, get to the repositories, find the books, and there you are. This is duplicated. So, in summary, what is this thing about MongoDB and the JVM? We love each other, and we are going to keep on loving each other till we burn our relationship. Which is going to be? Don't know. So, it's going to be here forever. Okay? Because Java is one of the most widely spread, particularly popular languages that everyone uses. I learned it in college. You guys learned it in college, I'm pretty sure as well, right? So, why did we start learning Java instead of anything else? Because it was actually the first decisive language that moved us away from mallocs and fallocs, right? Do you guys know what a malloc is? Thank God, right? Thank God we moved away from that. It allows us to do, bytecode languages where everything is compiled on just in time. It's very widespread. You can run Java on HP printers. Some of the most popular devices use some kind of Java on it, so you can build applications on it. So, there's nowhere we're going to get rid of Java anytime soon. And there's no a really good reason why to do it. It's a very nice technology. I really like Java. I worked a lot with Java, and I hope we can support it even better. So, 3.0 is coming, and the things that is coming in with is asynchronous connection, a little bit, because nowadays most of the connections we do need to be asynchronous. Does anyone know why? These devices. Okay? These devices demand a lot of asynchronous communication. Mobile, websites, interactive offloaded batch processing. If they all have asynchronous communication, we can do a lot more on per unit of time, in parallel, in concurrent way. Okay. This is why, for example, Node.js is becoming so popular. It's also because C# does not have any particularly good reason to use it, and Node is much better, and all the Windows users are starting to code in Node. But most of it is its asynchronousness, let's say, nature, that allows us to do a lot more parallel work. Okay. So a lot more integration with frameworks will come. Probably in the future is going to be coming some kind of integration with Play framework. Does anyone here know Play?
No.
Play is great. it's the next level of web application development in Java. It's like Python in Java. Okay, it's like very, very good. I really like it as well. There are multiple native drivers from MongoDB, as you could have seen. Python driver is evolving very much. Java driver is evolving very much. C, C++, C#, all of those are constantly being refreshed and renewed with new features of the servers. Tomorrow we are going to release a new version. So we are on party time. So I invite you all to come and drink a beer. Okay, 10 Gen pays for it. So, and we are going to have a new version just tomorrow. I invite you all to pay focus on it because it's going to have a lot more features in terms of application framework, in terms of integration with server security, SSL communication between servers and so on. So very nice features. If you are interested in finding more information, knowing a little bit more about MongoDB, please go to all these websites, contact us through info@10gen, be our guests. White papers, events, downloads, you name it. If you want more on this particular reactive Mongo, or Clojure, or Google Docs, or Morphia, these are all the links. I'll be sending the link, the presentation to this gentleman, so if you don't get it, ask him, not me. Okay, and this is all I have for you guys today. Okay.
Thank you.
Thanks.